Hi everybody, welcome to this channel. Today I want to go over linear equations in algebra. Before we get into solving examples, I'll go over some basics so I can carry you with me through the examples. First off, what is a linear equation? A linear equation relates two variables in the form of a line. What does that mean? Let's look at it. The general form of a linear equation is y is equal to mx plus b. Variables are represented in the form of letters in math. Why? Because they're not a fixed number. They could be any number. So because we do not have a fixed number, we represent them as letters. Y and x are variables. This is the vertical axis of your graph. And this is your horizontal axis. Some books like to use B for the coefficient. Some books like to use C. I prefer B, so I'm going to keep B. This is the coefficient. And M is the slope. These, when put together, draw a line on a graph. How so? Let's see. For example, if you visualize a graph, this is what it's going to look like. Now, this is your y-axis, and this is your x-axis. Y and x could be any number of things. X could be, for example, number of apples, and y could be money. How much does each apple cost? The number of apples a person buys and how much they pay for it can be a linear relationship. The more apples I buy, the more I pay. For example, if one apple costs $1, I can draw a line on a graph to represent that relationship. And it will look something like this. So if this was 1 and this was 1, this point falls right here on the line. So one apple costs $1. Two apples would cost $2, and so on. This is what x and y represents. B represents the coefficient. B is where this line touches the graph. This line right here touches the y-axis. In our case, it touches the y-axis at 0. When you buy no apples, it doesn't cost you anything. It could be a number depending on what the situation is that you're given. B is not always 0. M is the slope of the line. It tells you how steep your line is. And your line could be going upwards, or in some cases, it could also be going downwards. It just depends on the situation and the question you're given. Now, let me clear this out and give you some examples. Some examples of linear equations could be y is equal to 10. Y is equal to 2x plus 3. Or y is equal to negative a half x. Now let's look at number 1. Y is equal to 10. If I were to draw this graph, it would look like this. At the number 10 value right here, in y, I would have a straight line. Now why is that? Because the equation tells me y is equal to 10. So no matter what value of x I pick, y is going to be 10. When x is 1, y is 10. When x is 2, y is 10. When x is -5, y is 10, and so on. That is what this first equation means. Let's look at the second equation. For the second equation, we have y is equal to 2x plus 3. So we have y is equal to mx plus b. We have all the forms, all the variables of the general form. Now, what does this mean? If I were to draw this, you could create a table to get all the points in your graph, and this is how we can do it. We can say y and x. So when y is equal to 0, 1, 2, for example, and 3, let's go up to 4. We have to find the corresponding values of x. Or an easier way to do this would be, because your equation is already set in the form of y is equal to something. So we will say x is 0, 1, 2, 3, and 4. Over here, we will put these x values into our equation right here. So for 0, y is equal to 2 times 0 plus 3. So y is 3. When x is 1, y is equal to 2 times 1 plus 3. So y is equal to 2 plus 3, which is 5. For 2, y is equal to 2 times 2 plus 3, which is 4 plus 3, which is 7, and so on. Once you have these values, you can plot your graph. Let me go ahead and clear this out. Okay. Now, how do we plot this graph? We're going to have to put up some values. Say 1, 2, 3, and for the y, I'm going to start with 3. Let me start with 1. 1, 2, 3, 5, and so on. Now to plot this second equation, we're going to look at our values. When x is 0, y is 3. So that is our first point right there. And our second one, when x is 1, y is 5. And that's our second point right there. This will give us a line which goes in this way. So every x value is going to have a corresponding y value, which we can represent in this table in a tabular form or in the graphical form. So when x is 1, y is 5. When x is 2, y is going to be 7 over here, and so on. Now let's look at number 3. In number 3, we're given y is equal to -half x. This also means that our b is 0. We could write it down as plus 0. This is our b value. But that is assumed when it's not given. Our slope is negative. That means our line is facing or moving downwards. We can do a similar thing. We can create a table. Let's say x and y for some values. So let's say when x is 0, 1, 2, and let's see what y values we get. When x is 0, y is 0. When x is 1, y is -1/2. And when x is 2, y is -1. Now let's plot these on our graph. So here we have 1 and 2. And over here we'll have negative a half, negative 1, negative 1.5, negative 2, and so on. Again, this is our y, and this is our x. Now let's plot this. When x is 0, y is 0. When x is 1, y is a negative a half, right there. When x is 2, y is negative 1, over there. And we can create a line to represent this relationship. So for every x value, there's going to be a corresponding y value. And this y value, we can find it in the tabular form or in the graphical form. But it is important that you're able to visualize the graph when you're given these equations. Another thing the slope tells us, another way to look at it is this. Imagine I draw a triangle here. So what the slope tells us, that for every one value of x that we move to the right, we move half a value down for y because it's negative. That is what the slope means. You could also, it would be similar if our line was going up. For every unit of x, we're moving a certain number of units of y. Our slope, m, is y over x. In case for number 3, our slope is negative a half over 1, which we got from right there, which is a negative a half. So these are some basic concepts about what a linear equation is like. Let's go ahead and look at some examples and see if we can solve them. So this is the first example I have. This is from SAT Prep. And the question is, in 2014, County X had 783 miles of paved roads. Starting in 2015, the county has been building 8 miles of new paved roads each year. At this rate, how many miles of paved road will County X have in 2030? Assume that no paved roads go out of service. Okay, how do we begin? First, we need to identify our variables. Because we know we're solving linear equation questions, we can think of a graph. And now we need to figure out what is our x and what is our y. In this question, if I am to tackle it, what is it asking for first? It's asking for how many miles of road will be built. So we're going to say our y is going to be miles of road, and our x is going to be number of years, because the question is, how many miles will be in the year 2030? So our number of miles built and our number of years are related in a linear relationship. That is why it's a linear equation. So let's try to find what this linear relationship is. Let's try to find this linear equation. So let's see what information is important in this problem that we're given. So there's a couple of different things. First, in 2014, they started with 783 miles. That is too thick. Let me try to lower it a little bit. Okay. In 2014, County X started with 783 miles. And then every year after that, they have been building 8 miles each year until 2030. This is the information that we need to build our equation. So, where do we go from here? First, we're going to say that y is equal to our miles built, our total miles, actually, just miles, our x is going to represent number of years, and we're trying to look for how many miles are going to be built. So our y, our miles, are going to equal, it tells us in the question that they started with 783 miles. So first step is 783, because we already started with that, plus we've been building 8 miles every year, and x represents number of years. So this is the linear relationship between the miles and the years in this question. Now, the question asks us, how many miles of road will County X have in 2030? So first we need to figure out how many number of years is 2030 from 2014. So 2030 minus 2014 is going to give us 16 years. This is going to be our x value. So y is equal to 783 plus 8 times 16, which is 783 plus 8 times 16 is 128. Now, simply adding the two is 911. Now, what unit are we going to put here? What have we been solving for? We're solving for y, which is our miles. So 911 miles. And that is the answer to this question. By year 2030, we will have built 911 miles. Let's go to the next question. It's a continuation from the previous one, and the question is, in 2014, County X had 783 miles, and they built 8 miles of roads each year. At this rate, in which year will County X first have at least 1,000 miles of paved road? So now, the relationship is the same as the first question. So let's take our equation right here and put it right over here. Because it is the same relationship as the previous question. The only thing that has changed is, now they're asking us, instead of how many miles, the question is, let me highlight it for you, which year will it have 1,000 miles? So we're given the miles this time and we're looking for X. We're given Y. So let's plug in the numbers. Oh, change it. Okay. So over here, we're given 1,000 miles, which is our Y, is equal to 783 plus 8X. Well, now we have to find X. This is going to give us the number of years at which point we will have 1,000 miles of road. We have to apply some algebra here. So we're going to take our 783 and take it over there. And remember, this is positive, and when it moves across the equal sign, it changes to a negative. So this will become 1,000 minus 783, which is equal to 8x. 1,000 minus a 783 is 217. This is equal to 8x. Now we'll go ahead and move the 8. To move the 8, we have to divide. 8 and x are multiplied. It's 8 times x. So to move it across the equal sign, we divide both sides by 8. This 8 and this 8 canceled. X remains. And 217 divided by 8 is 27.125. And what is our unit here? Our unit here is going to be years, because we're solving for x, which is number of years. Now, in a question like this, you are not expected to represent the decimals in your answer, because there is nothing like 0.125 years. We can change it into days or months or some other form of time. So instead of saying 27.125 years, we're going to round it up to 28 years. This is just rounding. We are not rounding down because we're not moving backwards in time. We're going up. So it cannot take less than 27.125 years to build this. So we can't say it will take 27 years, but we can say it will take 28 years. Now, the question was which year will, it's not asking how many years will it take, it's asking in which year. And they started initially from 2014. So we're going to say 2014 plus 28 is going to be 2042. This is the year. So in the year 2042, they will have built 1,000 miles of road if they continue building 8 miles every year from 2014. And we got this beginning from right here, this linear relationship. We could represent it graphically if we wanted to. How would we do that? We would do x, y. We would write some points for x, and we would find the y value for those points. So when x is 0, y is 783. When x is 1, y is 791. And when x is 2, y is, let me see here, 799. And these values could be put on a graph. So set 1 and 2, and this is not drawn to scale. You would draw to scale on an actual graph paper, and you would have a linear relationship for this equation. So moving forward to the next question. Now this question is different. Try and pause the video here and try to solve it by yourself. See if you can find the right answer. So I'm going to go ahead and proceed solving it. Okay. So to edit a manuscript, Miguel charges $50 for the first 2 hours and $20 per hour after the first 2 hours. Which of the following expresses the amount C in dollars Miguel charges if it takes him X hours to edit a manuscript where X is greater than 2? So they're asking us to develop a linear relationship based on the restrictions and the variables they have already provided for us. So they're telling us that C is the dollar value of how much he charges. X is the hours it takes. And they also tell us that for the first 2 hours, he charges 50. And they want an equation where X is greater than 2. Now, this is the important part, because it changes how we approach the question. So, what are we going to do? So we know this C is our y-axis. That is what we're looking for. And we have been given information. He charges 50 for the first 2 hours. And we want an equation, an expression that tells us how much he's going to charge where X is greater than 2. And he charges 20 per hour for after the first 2 hours. So he charges 20 per hour after the first 2 hours. That means we're going to subtract 2 hours from our X. Additionally, we know that he charges 50 for the first 2 hours. So a 50, this is fixed. It doesn't change. It's a constant. This is a variable. It changes. Depends on how many hours you go for. And we're told that in our case, we always go for more than 2 hours. So he's always going to charge us 50. And then he's going to charge us some amount, 20 per hour, after the first 2 hours. I hope that makes sense. Now we're going to go ahead and simplify this. So C is going to be 20x minus 40 plus 50. I just multiplied the 20 by the x and by negative 2. And then C is going to be 20x plus 10. So our answer for this is B. If you're a little confused, I understand this question is a little tricky. But the main concept here is that we have a set amount that we're always charging, which is 50, which is this right here. This is our B. If you think about it in the form of y is equal to mx plus c, or plus b, this would be our B. And we're removing 2 here because we already charged them for 2 hours with this 50. And then this x is every additional hour after 2 hours that we are charging them $20 for. And that is how we get to this equation. Let's see the next question. A builder uses the function g defined by gx is equal to 80x plus 10,000 to estimate the cost, gx in dollars. To build a 1-story home of planned floor area of x square feet, if the builder estimates that the cost to build a certain 1-story home is 106,000, what is the planned floor area in square feet of the home? So we are asked to find the square feet of the home. And it tells us that the builder estimates that it's going to cost 106,000. And it also tells us that g of x is in dollars. So this is the cost. Now, this is just another way of saying these g and x are dependent. You could have just as easily said C is the cost or Y is the cost. This form does not change the meaning of the equation. It's just giving us G and X, saying that these two are interdependent. So we'll stick to G of X because that is what they've given us as our variable. And then we have X, which is the square feet. And they've given us the relationship. The relationship is this, which is given right over here in the question. And we're told the cost is 106,000. What is their square feet? This is very simple. Go ahead and pause the video, try to solve it yourself, and then resume the video to see how it's solved. So to solve this, I'm going to jump into it now, is very simple because we're already given g of x is the cost and we're given the cost is 106,000. So we're going to represent g of x as the value that we're given, 106,000, and this is our equation. And what we're told to find is the square footage, which is x. So this is what we're looking for. Now we're going to use some algebra to move things around this equation to find x. First, we're going to take this 10,000 on the other side. It's a positive on this side. So when we cross the equal sign, we'll change it to a negative. So it's going to be 106,000 minus 10,000 is equal to 80x. And 106,000 minus 10,000 is 96,000. So 96,000 is equal to 80x. Now, 80 and x here are multiplied, so we're going to divide both sides by 80. The opposite of multiplication is division, and if it was division, we would multiply both sides. So in this case, since it's a multiply, we're dividing both sides. Now we'll go ahead and solve the division. 96,000 divided by 80. This is 1,200. So our final answer is going to be x is equal to 1,200. This is 1,200. Solving this. So what is the units here? Our x is square feet. And the question is asking us how many square feet will be built for this cost. So this is our final answer. 1,200 square feet will be built. I hope this tutorial and this explanation helped you. If you have any questions, you can leave them in the comments. If this video helped you, be sure to like and subscribe. I will be uploading more tutorials going over linear equations, algebra. I'll be going over harder questions in the next video, and I'll also be uploading more math tutorials.